Okay, so this right here is the actual physical circuit that we've been discussing in this portion of the lecture. And I've built this with one of my favorite toys, the LabVolt Fluid Power Trainer. And so we're going to go ahead and walk through these components, the real components. What I suggest you go ahead and do is make sure you've got a copy of the hydraulic diagram as well as the ladder logic diagram. I have powered up the ladder logic with the power supply. It's a 24 volt DC power supply, and I want to illustrate something real quick before we actually get our system working, and that is the voltage across switches. Okay, so what I'm going to refer you to here is our proximity sensor 2 and proximity sensor 1 appropriately on our press cylinder. Okay, if you remember right, proximity sensor 2 was a normally closed being held open. So a held open switch should have 24 volts across it because we are using a 24 volt DC system. So if you notice my multimeter leads here, and you notice got some glare there, 24 volts across our system. So it's a normally closed being held open. How is it being held open? Again, our proximity detector is basically a magnetic interference detector. The piston is moved back into that region of effect, and it's opening our normally closed switch. Okay, so a normally closed switch, when it's closed, what should the voltage be? Well, it should be 0 volts. Let's go ahead and illustrate that property right now by moving our proximity detector. Okay, so you should hear an audible click. And there you go, there's an audible click. It's changed back to its normally closed state. What is the voltage across it now? 0 volts. Okay, so just illustrates a property. A closed switch has 0 voltage, an open switch has the full voltage across it depending upon its position within the circuit. So let's go ahead and hook up our proximity switch to in its correct orientation, and we'll go ahead and illustrate this system in proper operation.